Today we're going to look at a closer look at the normal table and how we can use it when we're solving problems. Assume female resting heart rates are approximately normally distributed with mean 74 beats per minute and a standard deviation of 13 beats per minute. So at the beginning here we're learning that we have an approximately normal population with a mean of 74 and a standard deviation of 13. The first question asks us, what is the probability an adult woman chosen at random will have a resting heart rate less than 60 beats per minute? So the first step I like to do when working on problems like this is to sketch out my normal distribution. And it can be a pretty rough sketch, but so here we have 74 beats per minute. That's our mean. I like to put on my +1 standard deviation, so we have 87 beats per minute, and -1 standard deviation, that's 61 beats per minute. Now this question's asking me about 60 beats per minute, and so I know that that is right here just below my 61 beats per minute, or my 1 standard deviation. It's asking me what the probability of an adult woman would be chosen at random would be less than 60 beats per minute. So really what it's asking about is this area down here in this tail. Well, what we know from the empirical distribution is that if we're within 1 standard deviation of the mean, plus or minus, that we expect about 68% of our population to be within 1 standard deviation of the mean. So out here, less than 1, we'd expect 16% to be out there. So one thing we can keep in mind is that we're going to expect that our answer be a little bit less than 16%. So let's just keep that in mind while we're doing our problem. Okay, so our first step will be, in order to use our table to find this probability, will be to standardize and find our z-score. So our z-score formula is equal to what we're observing, which is the 60, minus our mean over our standard deviation. So this specifically would be 60 minus 74 over 13. And when we solve that, we find out that our z-score is negative 0.08. And so we always round to the hundredths because our tables generally only go out to the 100th place. So the next step will be to look our z-score up on our table. So I have a table over here ready for us to look at. And it's a little crooked, but there we go. And so just a couple reminders about our table. When we look up our z-score, it gives us the probability of being less than whatever score we're looking up. This is good for the problem we're being asked because it's actually asking us about being less than 60. And so the z-score that corresponds with 60 beats per minute is negative 1.08. And so here's our z column. So we're going to go down here looking for negative 1.0. And here it is right there. And then we're going to find our 800ths over here along this row. And now we come over till we get to this number right there. And this, in fact, is the probability that corresponds with the shaded region when z is negative 1.08. 1.1401. Okay, so now let's go up here and write down what we found. So we have the probability, need my pen, the probability that x is less than 60 is the same thing as the probability of observing a z that's less than negative 1.08. And we found out what that probability is by looking on the table, and it was 0.1401, which is the same as 14.01%. and that's just under 16%, which is what we were expecting to see just based on the empirical rule. Okay, so let's take a look at the next question. What is the probability that an adult woman chosen at random will have a resting heart rate greater than 94 beats per minute? So this time, let's switch to red. This time we're talking about being greater than. So we're going to have to do another step in our problem. So 94 beats per minute could correspond up here to our above picture. And we're looking for the probability of being out here in this tail. So to start with, the process is going to be the same. The first thing we want to do is find our z-score. And that's still going to be our observed minus our mean over our standard deviation. So what we're talking about is observing a 94 minus our mean, which was 74, over our standard deviation, that's 13. And the z-score is 1.54. 2, we're going to the table. So now we're going to be looking up the z-score of 1.54. That's on the second page of my table. So let's enlarge this one over here. So we're going over to our z-score again. 1.5 is right here, and our 100th spot is 4, so we're going to look where these intersect, and we can read this number off of our table is 0.9382. Now remember, the 0.9382 or 93.8% corresponds to everything less than that z value. Okay? So if we were to write this out, we'd have the probability that x is less than 94, which is the same thing as the probability that z is less than 1.54. Oops. Is equal to 0.9382. So we're not quite done because we have to be careful. In our problem, we were asked about being greater than 94, and over here we have a less than sign. So this is, we want to remember that underneath this curve, the whole area is 1, and so this is really a complement that we're working on, and we can solve this. We can find the probability that x is greater than 94 by subtracting. So we can do 1, that's the total area, minus 0.9382. And, oh, I forgot, let's try that again. My eraser erased a lot. I just wanted to erase some. Okay, so 1 minus 0.9382, and that comes out to 0.0618, or we could write 6.18%. So we have to do an extra step when solving this problem because our table is set up to answer all the less than questions, and this one is a greater than question. Okay, so we have one last question to look at. How high would a female's resting heart rate be, have to be in the highest 2%? Okay, so what this question is looking at is what's going on underneath the curve. So to get started with, we might want to draw our standard normal again. So we have our standard normal, not very good drawn. And actually, we'll first look at our normal distribution for specifically for our blood pressures. So we have a mean of 74, and it's asking how high would the female's heart rate have to be? Like, so what number over here would correspond to having 2% being the highest 2%? So if this shaded region were the 2%, then what number would correspond with that? And so if we think about this with our standard normal, we can use our table again to solve this problem. So with the standard normal, we have our mean at 0, and we're still looking for the same idea. What cutoff, what z value here will give us a 2% over here, right? 2%. Written in decimals, that's 0.02. And so another way to think about it is that 98% are over here. So 0.98. So this number, the 0.98, corresponds to the inside of our z table. So let's take a look at the z table again, standard normal. And what we're looking for is where on the inside of the table we have a 0.98. So if we look inside the table, we're looking for the 0.98. That is going to be right around here. 0.98's between these two numbers, and in fact it's a little bit closer to this one. So we'll read our z-score, right off this table. So we were looking for an interior probability of 0.98, and that corresponds to a z-score of 2.05. So now we know, in fact, that this cutoff is 2.05. And now we're going backwards through our problems. Now we want to find out what resting heart rate would correspond to a z-score of 2.05. So what can we do? We can calculate, so use our z-score formula. So our z-score is equal to, remember, some observed value minus our mean over our standard deviation. Our z-score, we know in this case actually, is 2.05. We're wondering what value we're observing right here, so that's what we're looking for. We know our mean and our standard deviation. So we're going to use some algebra to solve this. We're going to multiply both sides by 13. And we get 26.65 is equal to x minus 74. Add 74 to both sides, and we get 100.65 beats per minute. Or if we were asked to round, we might round up to 101 beats per minute.